Hi, everybody. Welcome to the second session of Surface Chemistry. This is me, Ankita Menon, and today's topic of discussion is thermodynamics of physisorption. Just a quick summary of what we discussed yesterday. We discussed the difference between adsorption and absorption, right? Absorption is a bulk phenomena, while adsorption is a surface phenomena, wherein there are molecules which could be either be solid, liquid, or gases that gets absorbed on surfaces, right? And we discussed that there are two types of adsorption: physisorption and chemisorption. This is something that we learned. We learned the entire differences and comparisons between these two, and also we discussed about the factors that affect physisorption specifically, because that is our topic of interest. What are the factors that we discussed? We discussed about the effect of temperature, the effect of pressure, the surface area of adsorbent. You get a lot of questions from this, especially for GATE examination. Surface area of adsorbent and nature of adsorbate. And nature of adsorbate. So this is what we discussed yesterday. Now, depending on what we discussed yesterday, let's do a problem which was asked in CSIR November 2020. Okay, you can pause the video, note the question, try out the answer, and then resume. The question is, the correct statement about chemisorption is, so they are asking about chemisorption. Options are: results in multi-layer adsorption, no. Because chemisorption is associated with the formation of chemical bond, it leads to only monolayer formation. It is reversible in nature. No, it's not. It is irreversible in nature. Lower specificity than physisorption. Again, no. Why? Because it is associated with the formation of chemical bonds, it is highly specific. Highly specific. So, of course, option D would be the answer. And it states that occurs due to the formation of chemical bonds. Very easy. Even if you have not learned surface chemistry, by the literal meaning, you can answer this. Option D. Option D. All right. Now, continuing what was discussed yesterday, please note down the heading: cause of adsorption. Next heading: cause of adsorption. What are the reason? What is the driving force behind the adsorption of certain moieties on the surface? The only reason is it is due to residual forces. Occurs, please note it down, occurs due to residual forces. Residual forces, or it means unbalanced forces. Unbalanced forces at the surface of adsorbent. By now, I hope you understand the difference between adsorbate and adsorbent. Okay, so if you have a solid surface onto which there are gaseous molecules being attached, the surface on which the attachment happens is adsorbent. And the molecules that adsorb are adsorbate. Okay. Now, what is happening over here? Let's say that you have some surface. Okay, so I'm going to represent the surface. So let's say that this is a solid surface. And inside the solid surface, we are going to compare surface versus bulk. We are going to compare the forces at the surface. So now this is the surface, correct? Surface of whatever adsorbent we have taken. And any point inside this is the bulk, correct? So this is bulk. So I've taken a point at the surface and I have taken a point inside the bulk. So this is the surface, this is the bulk. Now, if you check the forces that act at these particular point, so let's take a point. I'll take a point on the surface. Okay. Now, if I take the forces that act At the bulk and at the surface, let's see what happens. So at the bulk, there are forces in all the directions. There are forces acting on or acted by whatever point that we have taken in all the directions. Why? Because this single moiety is surrounded by similar moieties. So this is the bulk. It is at the center. Correct. So it is surrounded by the same type of moiety, and as a result, the forces in totality surrounding the point that we have taken is same in all the direction. It is same in all the direction, and hence this particular stuff is balanced. Or the point that we have taken. So we were talking about unbalanced forces and balanced forces. So inside the bulk, whatever point that you take will be surrounded by similar type of moieties, and hence this is going to be balanced. While at the surface, if you take this particular direction, there will be forces because there are same moieties on the right and the left, at the bottom, but not at the top. Because here it is just air, while here you have the adsorbent. So there is a difference in the type of moieties that surround this particular point on the surface, and hence it is associated with unbalanced forces or residual forces. And these forces are responsible for adsorption to happen. Okay, these forces are responsible for the adsorption to happen. Why? Because there are unbalanced forces. Hence, what the adsorbent surface will try to do, it will try to balance the force. So if it has to balance the force, somebody has to come and sit on the top. Correct? And that's how they balance. So already we discussed yesterday under the nature of the adsorbent that higher the surface area. So we discussed yesterday that when you powder something, for example, powdered charcoal, or we can say that decreasing the size of the adsorbent, which we discussed yesterday already, increases the adsorbent, we said. Not adsorbent, increases the adsorption. Increases the adsorption. This is something that we said yesterday. And why is it increasing the adsorption? It is increasing the adsorption because as you reduce the size of the adsorbent, there is an increase in the extent of unbalanced forces, increase in the extent of residual forces. And it is because of the increase in the extent of residual forces that the adsorption increases. Okay, so if there is a question asking what is the cause of adsorption, the cause for the adsorption is the residual forces that are present. Unbalanced forces that lead to the adherence of some kind of moiety on the surface in order to balance them. Very easy. That is the cause of adsorption. Okay, next one. Next heading, please write it down. Thermodynamics of adsorption. Thermodynamics of adsorption. Okay, now this is actually explained based on an equation that is taken from thermodynamics again. You might be knowing this. It is delta G is equal to delta H minus T delta S. Okay, so delta G is the Gibbs free energy. Gibbs free energy. Delta H is enthalpy. T is temperature, you know. S is entropy. All right. Now, if you take any spontaneous process, now what do you mean by spontaneity? When do you say that the reaction is spontaneous? You say that the reaction is spontaneous if it does not require any driving force. Okay? No driving force is required. No driving force is required. For example, let's consider a waterfall. Water is falling from the mountains. It does not require any driving force. It happens naturally. And that is a spontaneous process. Let's say you have a balloon which is filled with air. A balloon which is filled with air. Okay. And the moment you release it, the moment you open it, the air expels out. So this expulsion of air from a filled balloon is spontaneous. But then will the air enter inside the balloon easily? No. We have to blow it. We have to give a lot of energy. And that is a non-spontaneous process. Okay, so this is one of the good examples where you can differentiate between spontaneity and non-spontaneity. So if you blow a balloon, fill air into it, you are giving some energy and hence it is non-spontaneous. But the moment you release the balloon, the air expels out and that is a spontaneous process. Okay, so now coming to the chemistry part. When you have a spontaneous reaction, your delta G will definitely be negative. So this is how you indicate whether a reaction is spontaneous or not. So if the value of delta G is negative, then you say that it is spontaneous. It is spontaneous. So we know that for a reaction to happen, it should be spontaneous. Otherwise, it won't be feasible. That is first thing. Now, other thing is about enthalpy. We already know from yesterday's class that enthalpy associated with adsorption is exothermic. It is an exothermic reaction, again, which means the value of delta H is negative because it is exothermic. Okay. Now, the next one is entropy. Entropy is something which is associated with randomness. Randomness. Higher the randomness, better the entropy is. So what can we see? What can we see? The thing that we see is if you have a solid surface, there are some random gaseous molecules. Upon adsorption, their randomness is reduced and they adsorb on a surface. So this state is highly random, correct? And here it is less random. So what can we see? We can see that the randomness of the system is decreasing upon adsorption. If the randomness is decreasing, delta S is also decreasing. Okay, initially, let's say it was 100 units. Now, after adsorption, the randomness is so low that let's say it is only 10. So, final minus initial, 10 minus 100 is delta S over here is minus 90 units. Or in other words, what I want you people to understand is entropy associated with adsorption is also negative. So now you have got all the parameters. Okay, you have got that if it is spontaneous, if the adsorption should be feasible, if it should happen, if it should be spontaneous, delta G will be negative. Already we learned that the temperature or the enthalpy associated, the temperature increases, right? We also discussed about an example where if we sit inside a room which is freshly painted, we feel that this temperature is slightly high. That is because it is an exothermic process and hence then delta H is also negative. And entropy as the randomness decreases is also negative. Now let's plug in all these values over here. Okay, so if delta H should be negative, delta H should be spontaneous and hence it should be negative. If that should happen, delta H we know is exothermic, that is negative, and then what you have is minus T delta S. We know that this delta S is also negative. Correct? Now see, this negative and this negative makes it positive. Correct? So now what you have is delta G is delta H plus T delta S because we have taken the negative sign of the entropy into consideration. Now this should be negative. Delta H is also negative. Now the question that should come to your mind is, at all the temperatures, will the adsorption be feasible? Will it be spontaneous? Answer is no. Why? Because If delta G should remain negative, if delta G should remain negative, I'll give you two examples. Let's say that in first case, delta H is minus 100 and T delta S is plus 20. In another case, delta H is minus 100 itself. Temperature got increased and now this is plus 200. So this is the condition of low temperature. This is the condition of high temperature. Now you tell me what are the values of delta G. So in the first case, delta G, what you get over here, minus 100 plus 20 is minus 80. While in the second case, delta G, the value that you get is minus 100 plus 200 is plus 100. So you can see that in the first case, at lower temperatures, as delta H was more negative than T delta S. Correct? Or in other words, what we say is modulus of delta H, that is the positive value that you take. You don't consider the negative value. Modulus of delta H should be higher than modulus of T delta S. Then only delta G will be negative. Very important. Okay. So if delta G has to be negative, if the process has to be spontaneous, the modulus of delta G should be greater than delta S, T delta S. You can see over here, modulus of minus 100 is 100. 100 is greater than 20 and hence it is feasible. Over here, modulus of minus 100 is 100. 100 is less than 200 and hence it is not feasible. Okay. So it is an extended explanation of what we discussed in the previous session. We said that as temperature increases, according to the Le-Chatelier's principle, we did say that as temperature increases, your adsorption, extent of adsorption decreases. Same thing. So as your temperature increases, the value of the modulus T delta S also increases. If that increases, what happens? Adsorption won't be favored. Adsorption will decrease. It's just an extended explanation of what we discussed yesterday. Okay. So based on this, a question was asked. Please try to do the question. This question was asked in 2012. Okay, take down the question, write it along. With increase in temperature, with increase in the temperature, the Gibbs free energy for the adsorption of gas on a solid surface, option A becomes positive from positive value. Option B becomes negative from positive value. Option C becomes positive from negative value. And option D becomes negative from negative value. Okay. So let's see what happens. This question was asked in June 2012. CSIR exam again. So we already know that delta G is delta H minus T delta S. And by default, if adsorption has to happen, this should be negative. So it will start from a negative point. Now, when you increase the temperature, so if T increases, what happens? T delta S also increases. If T delta S increases, what happens? Delta S is negative. This negative into this negative will become positive, and hence modulus of T delta S becomes greater than modulus of delta H. So if that happens, what happens? So we have already taken an example in the previous case. See? T delta S, whose value is 200, has now become greater than delta H, who is minus 100. So what is the total delta G? Plus 100. So that means it was negative earlier, but then now it has become positive. Correct? So as you increase the temperature, the delta G becomes more positive. So it becomes positive from a negative value. It becomes positive from a negative value. Okay. All right. Fine. So that is the end of the thermodynamics of physics option or adsorption. Now, the next one, what we have to learn is about the different graphical representations. Note down the heading. Graphical representations, very easy. Representations. Graphical representation. So among that, the first thing that you have to learn is adsorption isotherm. Adsorption isotherm. Now, what do you mean by isotherm? Isotherm. So see, iso means same and therm means temperature. So you are monitoring the extent of adsorption at same temperatures, or you can say constant temperature. So please note it down. What you do over here is you draw a plot of the extent of adsorption. So we will be learning about this in detail in the upcoming sessions. Extent of adsorption, which is notated by theta. So temperature is kept constant, so it depends on versus pressure at constant temperatures. So the temperatures are kept the same. Temperatures are kept the same, and the extent of adsorption is plotted against pressure. Okay, so if I have to just pictorially represent it. So this is adsorption, extent of adsorption theta versus pressure at constant temperatures. The way you will get it something like this. Okay. So we'll discuss how did this graph attain a plateau. We'll discuss that. Or if we want to discuss it now itself, let's do that. So this is about physisorption. So as you increase the pressure, your extent of physisorption increases, correct? So that is because there is more adhesion of the gaseous molecules on the solid surface and hence theta increases. But after a while, it attains saturation and this plateau notates the saturation. Okay? That is adsorption isotherm. Next one is adsorption isobar. Adsorption isobar. Again, very easy. Iso means same. Bar is pressure. So here what we do is, we monitor the extent of adsorption, notated by theta, versus temperature at constant pressures. Right. So again, if I have to pictorially represent it, you have extent of adsorption versus temperature. We know that as you increase the temperature, the adsorption decreases. Extent of adsorption decreases and it linearly drops. So this is the second graphical representation. Now the last one is adsorption isostern. Isostern. So here what we do is, important you note it down, here variation of temperature versus pressure at constant extent of adsorption. So here what we do is, if we plot the graph, we plot it as P versus T. Okay, P versus T. So your extent of adsorption is kept constant. That is theta. Theta is kept constant. Theta is kept constant. And you monitor how does the pressure and temperature change with extent of adsorption, and it is kept fixed. Okay. Now, if we have to explain this, see, we know that as you increase your pressure, your theta also increases. Correct? Your theta increases. But as you increase your temperature, your theta decreases because absorption decreases. This is something that we have been learning from the previous session and the first part of today's session as well. So let's say that you have a solid surface. You have a solid surface where there are some moieties of a gaseous substance. So it should remain like this. There should be always 5 gaseous molecule at any moment, even if you increase the pressure, reduce the pressure, whatever. Okay. Now what I'm trying to do is, listen carefully. Case 1 is where I increase the pressure. So if I increase the pressure, we know that new gaseous molecules will come and start adsorbing on the surface because pressure increases the extent of adsorption. Right. That should not happen. Adsorption should not increase. It should be kept constant. Correct? It should be kept constant. So if it should be kept constant, what we have to do? We have increased the pressure, which has increased the adsorption. So what we have to do is, to reduce the adsorption, we have to increase the temperature. So the moment we increase the temperature, gaseous molecules will depart. I hope you have understood it. Okay. So can you see they have got a linear relationship? If you increase pressure, you have to increase the temperature to maintain the number of gaseous molecules on the surface, and hence it is linearly increasing. Okay. You can either draw it T versus T or P versus T. Anything is fine. Okay. You will get a linear trend only. All right, so I'll just explain it once again. We have a solid surface on the top of which we have 5 gaseous molecules adsorbed. Now, if I increase the pressure of the gaseous molecules, more number of gases will come and adsorb over here, which I don't want. So I want these to go away. So if they have to go away, I'll heat it. I'll increase the temperature. So the moment I increase the temperature, desorption will happen because these are weak bonds, very weak van der Waals interaction, so they will leave. So increase in pressure is associated with increase in temperatures to maintain constant extent of adsorption. And this is a adsorption isotope. Stern. Adsorption isotope. All right. Yes. So with this, we come to an end of this video. See you in the next. I hope you're understanding the concept. If there are any doubts, please feel free to reach out. Bye.